Hello, my name is Olivia Robinson. I'm currently a sophomore environmental studies major, economics minor from Spelman College, and I'm from Louisville, Kentucky. This past summer, 2022, I participated in the Inspire U2 statistical program where my faculty mentor, Dr. Had, and I explored potential factors associated with public transportation ridership. My interest in this topic began when I first got to college. As I mentioned, I'm from Louisville, Kentucky, and the only public transportation system we have is a bus system and a few Amtrak routes. I found navigating the MARTA rail system to be a much less expensive option compared to Ubering around everywhere, and it also allowed me to explore Atlanta and familiarize myself with the city. I believe this research matters because public transportation is a form of transportation that uses less emissions than cars. The average commute by public transportation uses less than half of the same greenhouse gas emissions as that trip would emit by car. Public transportation alleviates road congestion, improves commuting mobility, provides equitable transportation options, and I believe understanding the factors towards what influences people's likelihood to take public transportation is the first step towards making improvements to increasing that ridership. For my studies, I examined heavy rail systems and light rail systems in the United States. Heavy rail systems are defined as a mass transit system that transports a large amount of people at once, and light rail is similarly defined, but more loosely, and just transports a less amount of people. Light rail, like I said, is more loosely defined, and also the data is sometimes combined with streetcars, which can present some difficulties and limitations with the data. So for my regression analysis, I used multiple regression analysis where I looked at groups of independent predictor variables and I looked at the relationship with one independent variable. So my independent predictor variable groups were rail system information, where I looked at length of the track, the number of stations, and the average distance between those stations to gauge a sense of access of where people can get on those stations and how far apart are those stations from each other. I looked at commute information where I looked at the total public transportation commuters, which includes other forms of public transportation such as trolley, commuter rail, bus systems, as well as those rail systems. And I also looked at the average commute times to work by public transportation and car. I also looked at city demographic information where I looked at mean income per capita, as well as the racial and ethnic compositions of the cities, specifically Black, Hispanic, and Latino, and white populations. My dependent variables were 2019 ridership data from the American Public Transportation Association. I looked at 2019 ridership, the raw unscheduled ridership, where I'm looking at the total number of trips taken on that system per year. And then I also scaled that number by the population, or by dividing it over the population to get a sense of how much of that percentage of the population was taking that system. So in summary, I found in my multiple regression analysis that more miles of track were associated with lower ridership, which may suggest that cities should focus on shorter systems. I also found that in my simple regression analysis, looking at the miles of track, it was actually more positively associated, meaning that a more expansive system, you might see higher ridership. I also found that more stations were associated with higher ridership, which may suggest that cities should focus on increasing more stations so that people have more access and more destinations to get where they desire to go. I found that longer car commutes were associated with high ridership, which this could be because those cities that are typically more congested tend to have longer commute times, but it's also those same cities that are more congested that tend to have more expensive public transportation systems. So looking at a city like New York or a city like Chicago, those are more congested cities, but they also have more expansive systems, which may be why there's higher ridership. I also found that higher public transportation ridership was associated with higher rail ridership. So this is looking at all forms of public transportation ridership. When there's a stronger relationship with people taking public transportation as a whole, there's also higher ridership. So this may be that improving other forms of public transportation methods that may be providing that access. For example, if someone's relying on a bus to get to that train station, then improving those other systems of public transportation will have a positive effect on ridership. And then also shifting public attitude and stigma surrounding public transportation. If you can introduce more riders into the public transportation group, then you can increase the amount of rail riders. And then lastly, I found that mean income and racial compositions were not associated with rail ridership. This does not mean that there's not a relationship on an individual level. When comparing that data among cities, there was not a positive or negative relationship, and the relationship was not strong enough. Thank you.